All right, welcome back, everyone. Today, we're going to be taking a deep dive into the world of resource
Oh,
extraction.
an exciting one.
I know. And it's funny, I never really thought about like optimizing how we dig stuff out of the ground, but then you sent me this chapter from a textbook, and it's
Mhm.
fascinating. We're talking everything from like AI-powered mining trucks to, get this, extracting ice from the moon.
And it's all connected by this idea of optimization. Like whether we're talking about a massive copper mine here on Earth or a future lunar base, the principles are surprisingly similar.
Really?
Well, absolutely. It's all about like maximizing what you get out, minimizing the costs, and doing it in a way that doesn't wreck the environment no matter where you are.
So we're trying to become like cosmic efficiency experts?
Exactly.
So this chapter, it lays out four main goals for optimization: operational efficiency,
Right.
cost minimization, which I think we all understand,
Of course, yeah.
resource utilization, making the most of what we've got, and then, of course, sustainability, which I'm already sensing some potential tension there.
Yeah, you've hit the nail on the head.
Yeah.
Because it sounds great. In theory, we want it all, right?
Sure.
But in the real world, those objectives, they often pull in different directions.
I see.
So for example, imagine a mining company that's got to choose between two different ways of processing the ore.
Okay.
One's cheaper, but it creates more waste. The other one's better for the environment, but it cuts into their profits. So those are the tough choices they're facing.
It's that classic battle between the short-term, like bottom line, and the long-term health of the planet.
Exactly.
It reminds me of the story I read about a company that actually saved money by investing in a more sustainable way to deal with their waste.
Oh, interesting.
And it turned out they were able to recover valuable byproducts from, like, the stuff they used to just throw away.
That's a perfect example of how sustainability and profitability can work together.
Mm-hmm.
They're not always opposed,
Mm.
and it really shows how important it is to, measure how well you're optimizing things.
Yeah.
We're not just going on gut feeling here. We're talking about, things you can measure, like the yield, the recovery rate, how much energy you're using, all of that.
So, like, if we're talking about platinum, we want to squeeze every drop of that precious metal out while using the least amount of energy possible.
Precisely. And that's where algorithms come in.
Okay.
They're like, the unsung heroes of this whole optimization thing.
Really?
They're crunching tons of data to help us make, well, smarter decisions.
Mm,
Now, I know you said you're not a math whiz,
definitely not.
but trust me, these algorithms, they're doing all the heavy lifting so we don't have to.
Okay, good. As long as they don't, start demanding royalties for their brilliance. But seriously, I am curious about, like, how do you apply these algorithms to something as, like, physical as digging rocks out of the ground?
Well, think about it. Even something as simple as planning a route for, like, a mining truck.
Okay.
You've got so many factors to consider.
Like what?
Like, where's the ore? How much can the truck carry? How do we save fuel? What's the terrain like? An algorithm, like linear programming.
Okay.
It can, like, take all that in and figure out the most efficient route.
So it's like a super powered GPS for these giant trucks?
Yeah, something like that.
That's pretty cool. But what about some of these more complex problems? The chapter mentions genetic algorithms. That sounds kind of sci-fi to me.
Oh, they're fascinating. Imagine you're trying to find the best way to drill through a tricky rock formation, right?
Huh?
A genetic algorithm, it creates a bunch of virtual paths, and then, just like evolution in nature, the best ones get combined. And the ones that don't work so well, they're weeded out, and eventually you end up with the best solution.
Wow. That's a lot cooler than anything I ever did in biology class.
I bet.
But wouldn't that take forever to, like, compute?
Well, that's where the power of modern computers comes in.
I
And it's not just brute force calculation. There's also this thing called simulated annealing. Basically, it helps the algorithm avoid getting stuck in a solution that's, good, but not the best.
Okay. That one sounds a little abstract. Can you give me, like, a real-world example?
Imagine you're trying to find the lowest point in a valley, right?
Mhm.
You might find a dip and think you're there. But simulated annealing, it's like saying, hey, what if we climb over that ridge?
Okay.
Maybe there's an even lower spot on the other side.
So it's like an algorithm with a sense of adventure.
In a way, yes.
I like it. But what about machine learning? It seems like that's the buzzword for everything these days.
It's a powerful tool. Essentially, it's about training computers to learn from data and make predictions.
Okay.
In mining, we can use it to look at geological surveys and figure out, like, the most likely places to find valuable ore.
So it's like having a digital prospector.
Exactly. And the more data it gets, the better it gets at predicting.
That's amazing.
Right.
Okay, I'm already seeing dollar signs. But hold on, it's not all fancy algorithms, is it? This chapter also talks about optimizing the actual processes of, like, getting stuff out of the ground.
You're absolutely right. The algorithms are great, but we still got to apply those insights in the real world.
Mm-hmm.
And one area where optimization is key is blast design.
Oh, explosions. Now we're talking.
Well, it's a little more nuanced than just blowing stuff up. It's about using explosives in a way that, like, breaks up the rock in the most efficient way.
Okay.
A poorly designed blast can create a lot of waste
Yeah.
and make it harder to get the valuable stuff out.
So it's like it's got to be a carefully planned demolition, not just random chaos.
Exactly.
Cool. So you
Alright.
blast the rock, then what?
Then you got to move it. That's where equipment allocation comes in. Sensors and GPS can help optimize the movement of trucks and shovels so they're not wasting time or fuel.
It's like a ballet of heavy machinery.
In a way, yes. And then, of course, there's the processing of the ore itself.
Right, right. Turning those raw materials into something actually valuable.
Exactly. That's where the real magic happens. We're talking about crushing, grinding, separating, refining, and every step can be optimized.
I bet sensors and data are important here too.
Oh, absolutely. By monitoring things in real time and tweaking the process, we can get the most out of the ore.
So it's like having a master chef in the processing plant, making sure everything's just right.
I like that analogy.
Mm.
And of course, we can't forget waste management.
True. What we leave behind is just as important as what we take out.
Absolutely. And it's not just about reducing pollution. It's also about, minimizing how much waste we create in the first place.
Right. But is there a way to, make mine waste useful?
There actually are some cool innovations in that area.
Really?
Yeah, some companies are finding ways to extract valuable byproducts from what used to be considered just waste, the win-win.
Well, I'm impressed. This is a lot more complex and interesting than I ever thought.
And we've only scratched the surface. We haven't even talked about all the new technologies that are transforming this whole industry.
Oh, you mean like artificial intelligence, the Internet of Things, digital twins, all those buzzwords.
Oh, they're much more than buzzwords. These are the tools that are shaping the future of resource extraction, both here and in space. And that's what we'll dive into next.
Oh, they're way more than just buzzwords. They're already changing how we think about getting resources, whether it's here or, out in space.
Okay, I'm all ears. Let's start with AI. Artificial intelligence, it seems like it's taking over the world.
All right.
How's it being used in mining?
So picture this. You've got sensors all over the mine.
Okay.
They're gathering data on everything, like how the equipment's running, what the rock's like, even the weather.
Okay.
AI can analyze all that data, in real time, and it can predict problems before they even happen.
So it's like having a crystal ball for your mind?
Kinda.
That's wild.
Yeah.
But it makes me think of those sci-fi movies where the AI gets too smart and decides humans are the problem. Well, we're not quite there yet. But you're right, there are some potential downsides to think about, like job displacement.
Right. Like, if the machines can do everything, what happens to the workers?
Exactly. As AI gets more sophisticated, it could automate tasks that humans are doing now.
That's a tough one. But couldn't AI also create new jobs, too? Like people who design and maintain these systems?
Absolutely. It's not a simple, robots versus humans situation. It's about adapting and making sure workers have the skills they need for this new landscape.
That makes sense. So AI is about making things smarter and, more predictable. What about the Internet of Things, IoT? I hear that term all the time, but I still don't really get it.
Okay. Think of it this way. The IoT is all about connecting devices to the internet. So in a mine, that means every piece of equipment, every sensor, they can all talk to each other.
So instead of just being DM machines, they're part of a big, smart network.
Exactly. And that lets us coordinate everything much more effectively. So sensors on the trucks could tell the shovels when they're ready to be loaded, and that saves time and fuel.
Oh, I see. It's like the whole mine becomes this giant, interconnected organism.
That's a great way to put it.
But then how do you, make sense of all that data?
That's where digital twins come in. It's
Yeah.
basically a virtual copy of the mine, down to the smallest detail.
Whoa.
So you can use it to run simulations, test different scenarios, figure out what works best before you make any changes in the real world.
So it's like a flight simulator, but for mining.
Yeah, exactly. And because it's constantly getting updated with real-time data, it's super accurate.
Wow, okay, you've officially blown my mind. But we have one more buzzword to tackle.
Okay, hit me.
Blockchain. I thought that was just for, Bitcoin and stuff.
Blockchain is way more versatile than that. It's basically a secure and transparent way to track transactions and data.
Okay. So how does that work in mining? Are we talking about like paying miners in cryptocurrency?
Not necessarily. Think about something like cobalt.
Okay.
It's used in batteries for electric cars and stuff.
Right.
But there are, concerns about where it comes from,
Right.
whether it was mined ethically.
Right.
So blockchain can be used to track that cobalt from the mine all the way to the finished product. So you know exactly where it came from and how it was produced.
Oh, that's a good idea. It's like giving each piece of cobalt its own little digital passport.
Yeah, I like that. And then consumers could scan a code and see the whole history. Makes everything much more transparent.
That's really cool. Okay, I'm convinced. Blockchain for the win. But let's get real for a second. Are these technologies actually being used in mines today, or is this all still like futuristic stuff?
Some of it's still in development, but there are already companies putting these ideas into practice.
Really? Give me some examples.
All right. So Rio Tinto, the big mining company, they've been using autonomous trucks for a while now.
So, like self-driving dump trucks.
Yep. They use GPS, sensors, and AI to navigate the mine,
Hmm.
haul stuff around, even refuel themselves.
That's both kind of scary and super cool.
It is. And it's
Mhm.
safer because you don't have human drivers in dangerous areas. Plus, it's more efficient because they can run 24/7.
Oh, I see. Makes sense. Any other examples?
Yeah. Vale, a Brazilian company, they've been using AI to optimize their iron ore processing. They've managed to significantly increase their recovery rates.
Meaning they get more iron out of the same amount of ore.
Exactly. That means more profit and less waste, which is good for everyone.
Okay, I'm liking these real-world examples. It sounds like we're making progress towards like a more efficient and sustainable future for mining. But what about space mining? That seems like a whole other level of difficulty. How do you even begin to optimize for something like that?
Space mining is definitely the next frontier. It comes with its own unique set of challenges,
Yeah.
but the potential is huge.
I can only imagine. It's not like you can just call a tow truck if something breaks down on the moon.
Exactly. Reliability and efficiency are crucial out there. And that's where some of the technologies we talked about come in. For example, NASA is developing these robotic miners that can work autonomously on asteroids.
Like little robot prospectors going out into the asteroid belt.
Kind of. They can navigate the surface, identify resources, even extract materials without humans having to control them directly.
That's amazing. But how do you make sure they don't like get lost or break down millions of miles from Earth?
Well, NASA uses these super sophisticated computer models to simulate the conditions on asteroids, like the gravity, the terrain, what the rocks are made of.
Oh, okay. So it's like they get a virtual training course before they're launched into the unknown.
That's a good way to think about it. And because communication with these robots can be delayed by like minutes or even hours, they need to be able to make their own decisions on the fly,
So they need some AI smarts on top of their mining skills.
for sure. They have to analyze data, identify the good stuff, plan their moves, and even learn from their experiences, all without us humans constantly telling them what to do.
Wow, that's impressive. It sounds like the future of space mining depends on these like super smart, rugged robots. But it's not all about robots, right? What about optimizing like the whole way we use resources in space?
That's where this idea of in situ resource utilization comes in, ISRU for short.
Right, sorry, yeah, okay.
It's about using what we find in space to support our activities there,
Mm.
instead of having to haul everything up from Earth.
Right, like using water ice from the moon to make fuel or even like air to breathe. That sounds incredibly efficient, but also super challenging.
It is, but the payoff is huge.
Yeah.
ISRU could make space missions way cheaper and less complex, which means we could have a real long-term presence out there. But it definitely requires some creative optimization.
So how do we make ISRU happen? What needs to change?
Well, we need to develop technologies that can work in the extreme environment of space, like intense temperatures, radiation, no atmosphere.
Yikes. So basically, you're trying to design a mine that runs on a shoestring budget in the middle of nowhere and can't afford to break down.
Pretty much. But engineers are brilliant, and they're working on some amazing solutions.
Like what? Give me an example.
3D printing, for one. Imagine building structures, habitats, even tools and equipment right there on the moon or Mars using the materials we find there.
So instead of shipping everything from Earth, we could like 3D print what we need using moon dust or Martian rock.
Exactly. And 3D printing is way more flexible than traditional manufacturing. We could create things that are perfectly suited for the environment, which means less need for heavy shielding and complex life support.
Wow. That's like straight out of science fiction. But it's not just about the technology, right? It's also about how we manage these resources in space.
Absolutely. As we, expand out into the cosmos, we need a whole new set of rules and practices for responsible resource management. We need to make sure everyone benefits from these resources and that we're not messing up the environment out there for future generations.
It's like we're writing a whole new chapter in the story of humanity, and optimization is like a big part of that story.
Exactly. And it's not just about writing it. It's about living it responsibly and sustainably. And that's where this conversation gets really interesting.
Yeah, it does feel like we're, right on the edge of something big. But before we get too lost in like dreams of moon bases and asteroid mines, let's come back to Earth for a minute. What are some of the like big challenges we got to figure out to make sure all this optimization actually leads to a more sustainable future for, mining here on our own planet?
One of the biggest, and we've kind of touched on this throughout our deep dive, is finding that balance
Yeah,
between economic growth
right.
and protecting the environment.
Hmm.
It's easy to get caught up in, oh, we need to be efficient, we got to make profits,
Yeah.
but we can't just do that, and ignore what it's doing to the planet.
Yeah, it's like trying to outrun your own shadow, right? You might make some progress for a little while, but eventually those like unsustainable practices catch up with you. I guess the big question is how do we shift our thinking away from just taking to something that's more like regenerative?
That's the key. We've got to move past this take, make, dispose mentality and
Mm.
start thinking more circularly.
Circularly.
Yeah, like viewing waste as a resource, designing things that can be reused, prioritizing renewables, closed loop systems, stuff like that.
So instead of just digging stuff up and tossing it out, we're talking about like an economy where materials are always being recycled.
Exactly. It's about mimicking like the natural cycles we see in nature. The waste from one process becomes the input for another. And optimization, all this data analysis, it's crucial to making that work.
Okay, I think I'm getting it. It's not just about making a few tweaks here and there. It's a whole different way of thinking about how we use resources, right? It's got to be designed to last, not just for like quick profits. Yeah.
Exactly. And it's not just companies, it's all of us.
Hmm.
We need to understand that the resources we rely on, they're not infinite.
Right.
We've got to use them carefully, responsibly. We have to make good choices as consumers, support companies that care about sustainability, and push for policies that, encourage responsible resource management.
It's like we're all part of this, right? We all have a responsibility to build a more sustainable future. But let's zoom back out to space for a sec. We talked about like the technical stuff and the benefits of space mining, but what about the ethics of it all? Who owns the stuff out there? How do we make sure space mining doesn't just become like a free-for-all for the richest companies?
Those are the million-dollar questions. And honestly, there aren't easy answers. The rules are still being worked out, and there are a lot of different opinions about, how to manage these resources and who should benefit.
It's like the Wild West all over again, but instead of gold rushes, we're talking about platinum asteroids and like helium-3 on the moon. It's exciting, but also kind of scary.
It is. And that's why it's so important to have these discussions now, before things get out of hand. We need clear rules that ensure everyone has a fair shot, that we protect the space environment, and that all of humanity benefits, not just a few.
So basically, we need to take that same sense of responsibility and sustainability that we're trying to develop here on Earth and apply it to how we explore and use space.
Exactly. We can't just repeat the mistakes of the past.
Mm.
We have to learn from our history and make sure we do things right this time. Be good stewards of the cosmos, so
Yeah.
to speak.
Well said. I think this deep dive into optimization has been like eye-opening. It's a complex topic, and we've only scratched the surface. But one thing I hope our listeners take away from this is that optimization, it's not just about numbers and
I mean,
algorithms.
it's bigger than that.
It's about finding solutions that, consider the economy, the environment, and people. It's about building a future where we can thrive without, like, using up everything that sustains us, both here and out in space.
I couldn't have said it better myself. It's a tool, a really powerful one, but it's up to us how we use it. We have to be aware of the choices we make, the technologies we develop, the systems we build, always aiming for that balance between progress and sustainability. The future really is in our hands.
Well, that's a great place to wrap things up, I think. Thanks for joining us for this deep dive into optimization.
It's been a pleasure.
And to our listeners, as you go about your day, think about how you can apply some of these ideas to your own life. Whether it's finding a more efficient way to get to work, using less energy at home, or even just like making more conscious choices about the things you buy. every little bit counts. So keep exploring, keep learning, and keep optimizing.
Until next time.